Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 to 95. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport runway 1449, Lszh localizer, landing around the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. That displays the airspeed indicators, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, and the vertical rate of climb descent of the aircraft in 10,000 feet per minute. All the stiffness of the trigonometric angles in degrees. Again, climb and descent. We have also the artificial horizon with the altitude indicator, the pitch ladder in degrees, and the bank angle in degrees. We have also the ILS localizer, the instrument landing system of the threshold antennas that transmit a radio frequency from the threshold antennas of the runways we use for takeoff and for landing. So we have to align the aircraft with the horizontal localizer, the vertical glide slope. The aircraft onboard antennas receive the radio frequency from the ILS localizer, the instrument landing system of the airport runways we use for takeoff and for landing. Each time we have to set up a new frequency, a different frequency for either runway, and also magnetic north pole heading we use for takeoff and for landing. So we have runway and airport. So we have also we have the flight director crossbus for manual guidance of the aircraft and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode announcing of the autopilot and the autothrottle. Later on vertical navigation modes, we have also the outside, the horizontal situation indicator with the magnetic heading and track. Also the integrated display of the flight plan we use. We input all the flight plan one by one waypoints from the flight management computer. So we create a route that can be followed also by the autopilot flight director system panel also later. So we have also the display, the navigation display that displays the horizontal and vertical profile of the aircraft as well as the GPS position of the aircraft, the magnetic north pole and the geographic north pole, and the magnetic variation depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the terrain with the red, green, yellow, and amber color indication. Also, depending on the distance the terrain is away from you, will display different colors like red, yellow, and green. Also, how far the aircraft is flying above the terrain. You will see later when we fly, it will display also the altitude from the radio transmitter antenna. That can calculate the signal, how far we are flying above the ground. We have also the terrain map. We have the airports where they are located with a 4-letter account name. Our own airport, the Lszh, Zurich International Airport in Switzerland. We can see the runways we're gonna use for taxiing, the taxiways, and also the runways we're gonna use for takeoff and for landing. So we have also the runway heading and the runway length. You can see also the navigation aids, the nav aids, which are the workstations, ADFs, and the Bs, and the waypoints. The waypoints, which are horizontal and vertical navigation fixes and altitude and speed constraints. We have to fly through some waypoints. As I told you, we're gonna set up the flight management computer a complete flight plan later. One by one waypoint is gonna be connected with a purple format Z line. You will see it in the navigation display. We can connect also the autopilot when we fly using the flight management computer flight plan we're gonna create. So we have all these things. We have also the waypoints. We have also the other aircraft that fly around our own aircraft using the transponder are displayed in the navigation display with a diamond shape, and the altitude difference of the other aircraft in hundreds and thousands of feet, and also a plus or minus sign if they are above or below our aircraft, how many hundreds and thousands of feet are above or below our aircraft. Also whether they climb or descend with respect to our aircraft, it will show us an arrow up or an arrow down. So we have the transponder. It can calculate the other aircraft position and distance from our aircraft up to 40 nautical miles or 72 kilometers away from our aircraft in a 72 kilometers 360 degrees radial around the aircraft. It can also calculate with its computer from the radio frequency changes. It can calculate the other aircraft altitude difference, how many hundreds and thousands feet are above or below our aircraft. Also, it can calculate whether they climb or descend with respect to our aircraft. It can also calculate the velocity closing in between our aircraft and the other aircraft. It will show us a warning from the TCAS system, the Traffic Collision Advisory System. We have an incoming collision in the air, so we have to make an avoidance maneuver in the air. Also, when we are in the ground or when we take off and land, we can see the aircraft that are positioned in the runways and the taxiways, which are parked in the airport, for instance. So this is the TCAS system and transporter, how to use it. So I will show you also the rest of the systems of the aircraft, the engines indication, the thrust levers, also the flight controls that I use here. So you can see here I have the side stick, the Lszh Extreme 3D, as you can see, that controls also the mouse pad and the keyboard from the computer to control all the instruments here, like the autopilot, flight director system panel, the flight controls here. So you can see I can climb and I can descend, I can make turns to the right and to the left. When we fly, you're gonna see I'm gonna use the side stick input. So it's identical to the Airbus aircraft. We have the side stick priority, left or right, or dual input. We have the autopilot disengage, the push to talk button. So you can see the controls, climb, descent, like this, very easy, very simple. Also the thrust levers over here, we have the thrust levers here, increase and decrease. So you can see the percentage of the engines we use when flying. If we increase the thrust levers all the way up, it will display dedicated thrust commanded by the Flught. So you will see the red warnings here will not configure for takeoff. You can see also an aircraft is coming up for landing over here. So you can see the displays here. We have the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot flight director system panel 200 knots, the radio altitude above the ground, barometric altitude, the altitude tape, this increase or decrease the altitude. Also this is the vertical rate of climb and descent of the aircraft. You will see how fast the aircraft climbs or descends depending on the needle movement. So we're gonna see also, we can see the same information here in the head-up display. When we fly, you can see the airspeed indicated, the barometric altitude, the airspeed selected, and the altitude selected from the autopilot. The flight director, takeoff, go around here also. The HSI, horizontal situation indicator. So you can see now here we have an incoming aircraft, a Boeing 737 for landing. So we just spotted that. So it's coming for landing. 737-800, as you can see. So we have also just touched down in the runway. So we have also, you can see the airspeed selected over here, the autopilot panel on this surface. So we have the autopilot engage and disengage, the auto throttle left and right, engage and disengage, the flight director on and off, engage and disengage, the LNAV and the VNAV, later navigation, vertical navigation. So this is the airspeed in nautical miles right now. Can change to Mach, climb continues, auto throttle, flight level change. The heading in degrees, we're gonna use the heading of the runway. Also vertical rate of climb descent, the altitude selected, and the VOR localizer and the approach for autoland. You can see both sides here are identical, the captain and the first officer. As you can see, we can set the barometric pressure inches of mercury or hectopascals when we take off. We need the barometric altitude. We have the Minimus radio, plan map menu, the range in nautical miles, weather, accept, cancel, reject some warnings, and the display over here. Also systems, CDU, control display unit, info, checklist, communication, navigation display, ACAS, sensing. So you will see all the info we need. You can see the barometric pressure set in the primary flight display over here already. So we have the barometric pressure 29.92 inches of mercury on 1013 hectopascals. It's what give us the barometric altitude every time we fly. So above 18,000 feet we're gonna set 29.92 standard barometric altitude for flying in the US. So we can see here the vertical rate of climb descent 500, 1000, 1500, 2000, 3000, 6000. Using the needle move up when we climb, move down. When we descend the pitch ladder over here in degrees, you can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. Also the bankroll of the aircraft in flight, the flight director, FMC, takeoff, go around, thrust set. So we have radio altitude -2 right now. It will display up to 2,500 feet. Barometric pressure, as I told you. You can increase or decrease the altitude displayed by changing the value here. Now we have 1013 hectopascals, so 39.92 inches of mercury. So we can use either one, and the starter. So we have the range is 18 nautical miles for the display here for the navigation display. You can see the Düsseldorf airport over here, DTL. In the map displayed 18 nautical miles is the maximum right now. Display, you can see map or plan. So we have the displays over here. You will see later. So the plan display over here. So you will see the map. You have the terrain 4,700 feet above the ground level, the red and the yellows. You'll see also when we fly. how far above the ground we're gonna be flying. Another aircraft in the air, also the flight plan. So we have a few more minutes. We're gonna create the flight plan over here using the flight management computer here. Input all the data later using the keyboard and the display. Also the mouse pad here to control it. So the thrust levers, we activate the thrust. We have the takeoff, go around switch, the auto throttle, disengage, this switch disengage the auto throttle. Over here the thrust reverse, the fuel control left and right engine, the speed brakes over here, also extend and retract like this. Speed brakes extend, the flaps position over here. So we need the other flaps increase or decrease, setting up for landings and takeoff. So I'll talk to you about the engines indication later. You can see we have the stabilizer trim position over here. We can trim the horizontal tail trim stabilizer when we fly. It's 4 degrees from now. Inside the green bar is for takeoff. The stabilizer trim, the rudder trim is 0 right now. As you can see, rudder trim 0. So stabilizer trim 4 degrees over here. Cabin altitude. When climbing the aircraft, it will increase to like 6,000 or 7,000 feet. Inside the cabin, 8,000 maybe maximum rate of climb descent. Differential pressure. So when we climb to 45,000 feet, the cabin altitude should be 6, 7 or 8,000 feet, and the differential pressure 7.8 or 8 psi pounds per square inch inside the cabin, between inside and the outside. So we open and close the outflow valve either manually or automatically to pressurize or depressurize the aircraft cabin when we fly. You can see flaps position right now over here. The landing gear extend and retract over here. The alternate gear, the lock override, the retract and extend speed, the auto brakes, rejected takeoff, when auto brakes for rejected takeoff or disarm or for landing later. You will see how we arm them. It's very important the stabilizer trim when flying. I'm gonna show you now. So gross weight for takeoff and total fuel on board. So you will see also the engines indication. We take a bleeder pressurizer from the engines, usually most aircraft, to pressurize the cabin of the aircraft when flying. Also the hydraulic fluid tanks, other systems, wing and engine anti-ice over here. So hydraulic fluid tanks need pressurizer from the engines. Anti-ice needs pressurizer, cabin pressurization, air conditioning, ventilation and oxygen in flight. So pressurization, you can see the outflow valves here in the manual. We use the outflow valves, climb, descend, open and close to pressurize or depressurize the cabin when we climb or descend. It changes altitude. So in the auto we don't need to do nothing, it's automatic from the computer of the aircraft. So we have here a few more things to see. Also the flight controls. So you will see now the horizontal tail trim stabilizer, how to trim the horizontal tail of the aircraft when you fly. Also we're gonna set the flight management computer. So we have here, you can see the flight controls, climb, descent. Also make turns to the right, to the left. Also we have the rudder pedals here. We can control the vertical rudder and also the nose wheel of the aircraft together. When we are in the ground and steering the aircraft, we can use both the rudder here, as you can see, rudder control, left and right turns, and also both the nose wheel together. So we'll talk to you about these things now. Also the elevator, climb and descent. Like this, you can see we can also trim the elevator or the whole stabilizer, depending on the aircraft. For climb and descent, also maintain level of the aircraft in flight. So you see how easy it is to make turns left and right. Climb, descent, also use ailerons and spoilers like this, left turn. In the Airbus, left and right turns. In the Boeing also we use the yoke for controlling the flight controls. So I'll talk to you now about the Newton's physics, about aeronautical and aerospace engineering, show you some principles we need to know for flying the aircraft, the Boeing 787 or any aircraft, for the air transfer pilot theory, and the commercial pilot license, the air transfer pilot license, the commercial pilot license, the theory of flight and aerodynamics, Newton's physics, and the Bernoulli theory of fluids. We need to know. So you see here the outside view of the aircraft. We have the surface area of the wings. When we fly the aircraft, the weight is divided over the surface area of the wings. That makes the lift from the forward thrust of the engines that overcomes the drag. When we reach an airspeed like 200-250 kilometers an hour, the airflow is enough to create an aerodynamic lift to lift the aircraft up into the air. So the lift acts over the center of gravity over here, where the engines are located. So we have the thrust from the jet engines. You can see we have the high pressure compressor turbine over here, and the high speed Saturn shaft in the back section. Also we have the low speed Saturn shaft, low pressure compressor turbine in the front fan. Also from here we have the bypass air. You can see the bypass section from the front fans. Also we have the thrust reversers, so the bypass air. We have the fuel over here. The fuel is coming down to the engines from the left and the right wing fuel tank. So you can see we have two engines for symmetric thrust. Also left and right wing fuel tank, the fuel booster pumps over here, and the fuel valves, low and high pressure fuel valves. So we have 30% and 30% in the left and the right wing, and 10% in the center wing fuel. We have also the wing and engine at the ice over here section in the front. It takes bleed air from the engine, which sends to the manifold and then comes back to heat up the wings and the engine nozzle. So we have also you can see the bottom surface of the wings. When we fly like 200-250 kilometers an hour, the airflow is moving faster below the wings, which pressurizes the aircraft weight and wings up into the air. This is the lift. And we have above the wings the airflow is moving faster, so there is also lower airflow below the wings and faster above, which sucks the aircraft up into the air. We have lower pressures, the mean aerodynamic chord, 23% of the Mach, where the maximum aerodynamic lift occurs. Also the center of pressure is moving back and forth over here. Also the airflow becomes detached, and we have the stall of the wings over here when we fly. So we need to pay attention over here in the primary flight display. You see the airspeed indicated. When we fly, we're gonna see the stall speed is gonna be displayed with a yellow and red indication just below the airspeed. Also the angle of stall. We need to avoid stalling the wings, so we press the side stick down or the yoke and advance the thrust levers to increase the airspeed. This is stall avoidance maneuver. So we have mean aerodynamic chord. Center of gravity here is the yaw axis, where the mean aerodynamic chord is. So the yaw axis or center of gravity is, you control the vertical rudder and the nose wheel in the ground and the vertical rudder in the air mostly. So you use the rudder to make left and right turns in the air like this, using the rudder pedals over here in the cockpit. Rudder pedals left and right. You can see left and right the rudder pedal, so you make directional steering. Also we have the vertical rudder in the ground when we take off or when we taxi. The nose wheels can control it with the rudder pedals, 76 degrees left and right turns, up to 45 knots or 72 kilometers an hour. Then the rudder becomes aerodynamically effective to control the aircraft, so the computer will automatically decrease the deflection of the forward nose wheel from 76 degrees to just 7.6 left and right. Then as we increase for takeoff the airspeed above 80 knots or 144 kilometers per hour, the forward nose wheel is going to be locked to zero deflection or like half 1 degree. So we're going to be having together for takeoff and for landing. After landing also is the inverse. So above 144 kilometers an hour we have the rudder only to control the aircraft until we take off, then not flying. Then when we land we have the inverse. As we land, first we have the rudder, then as we slow down below 80 knots the forward nose wheel becomes activated from the computer. So we have another aircraft for landing. So the control the rudder pedals You can see we have the tiller also just for the nose wheel, the rudder pedals together, nose wheel and rudder in the ground, left and right turn. I have it in my joystick, both sides are interconnected, the captain and the first officer. In the Boeing also the yoke is interconnected, in the Airbus it's just the rudder pedals and the joystick inputs. So we have here, you can see one more axis here is the pitch axis. From wingtip to wingtip we use the joystick in the Airbus for climb and for descent. Take the weight up, climb, take the weight down, descend, like this. So very easy, as you can see. So we have in the Boeing also, we use the control column, the vertical column of the yoke, climb and descend instead of the side. You can see the deflection is identical, proportional, the yokes and the side stick when I move it back and forth. So take the weight up, climb, take the weight down, descend. Also we have one more axis here from nose to tail. It's the longitudinal axis. In the Airbus you have the side stick, left and right turns like this. You can see we use the differential pressure between the left and the right wing, the ailerons, spoilers and flaperons in the Boeing, ailerons and spoilers in the Airbus. So we make left and right turns very easy, very fast to control, like in a fighter's aircraft. When flying soon, it's also fly by wire aircraft. It has flight control computers to control the input, like in the Airbus aircraft. So you can see the spoilers now fully extended, also the flaps, the ailerons here, left and right ailerons, and the flaperons here, left and right. So we have all flight controls together like this, interconnected. So you can see this is the control wheel, make left and right turns like this. Ailerons and spoilers in the Airbus joystick and ailerons spoilers in the Boeing. You use the control wheel of the yoke like this, very easy, very simple. So I'm gonna show you now one more view of the flight controls of the Boeing 787, and then I'll show you the rest of the systems. So you will see now this view of the flight controls of the Boeing 787. Hope you like it. So you can see here we have the joystick again. You can see here also better view of the display, how we control the yoke over here, the control column over the Boeing's left and right side are interconnected like this, climb, descend, make turns to the right, to the left. So use the horizontal trim stabilizer like this also. So we make turns, left and right turns, ailerons and spoilers, climb and descend like this, as you can see. Make turns to the right, make turns to the left. You can see also over here the side stick, you can see the thrust control. I can actuate the engine's thrust over here, the thrust from the jet engines, forward and aft. So hope you like the side stick is identical to the Airbus side stick, as you can see. You can see climb, descend, make turns right and left like this. How fast the input is applied over here. So hope you like my side stick, the Lszh Extreme 3D, and the yoke of the Boeing aircraft. So climb, descend, make turns to the right, rudder pedals, and horizontal trim stabilizer. Very simple. Very easy. Also the outside view. One more view here. So climb, descend, rudder pedals, right, left, ailerons, spoilers. So climb and descend, rudder pedals. Also, so climb, descend. Also this view. So this is enough for the flight controls of the Boeing aircraft tonight, for the Boeing 787. As you can see, so we go the rest of the systems right now. So I will show you the horizontal tail trim stabilizer right now. I will explain you its function, then the flight management computer, and the rest of the system. We're gonna make a complete flight after a few minutes. So you can see here we have the horizontal tail trim stabilizer. Over here we can trim the horizontal tail like this when we fly. I trim the elevator up and down like this. Also climb, descend, very easy to control. So we need to control the horizontal tail elevator stabilizer manually. So in the display you can see the flap speeds also displayed. So we have the tag here. You can read from the tag over here. So it says elevator trim, left click down, right click up like this. So we trim the elevator, left click down, right click up. So this way you trim the elevator up as you fly, and you pitch the nose of the aircraft up. You have this aerodynamic effect. This way you trim the elevator down, and you pitch the nose of the aircraft down. You have this aerodynamic effect. You have also the control wheel here to control the aircraft, as you can see when flying. So I hope you like it. So you can see the elevator trim. Left click down, right click up. So very easy, very simple. You feel it when you fly. It changes the attitude of the aircraft. So you see how many degrees you trim the elevator up and down, the stabilizer trim. Over here you have the rudder trim also to remember if you need any. So you have here the alternate trim switch. You can see alternate pitch trim, elevator up and elevator down. So this way you trim the elevator up, you pitch the nose up, and this way you trim the elevator down and you pitch the nose down. So very easy to use and to remember. These two switches, this is the alternate channel with flight control computers. The other one was the manual. Also we have the parking brakes here, on and off set. So use alternate trim, nose up as you can see, and nose down pitch trim. You can see also we have satellite communication here, very high frequency, tune active and standby, ground proximity, weather radar, transporter. So this is the radio communication panel, the fire extinguishers for the left and the right engine, transporter, rudder trim, radio management panel over here. So we have the stabilizer trim cutoff switch over here, also very important. So you read again stabilizer trim, how many degrees, like this, trim the elevator up and down. And we have the stabilizer cutoff switch. If you have failure either of the left or the right stabilizer trim system because of a failure of the hydraulic system over here, because this is a fly-by-wire aircraft, it has flight control computers. If the hydraulics fail and affect the flight control, primary flight control computers from normal to alternate or direct mode or mechanical backup, you have to come down here and disconnect the switch. You can see you're gonna lose the autopilot and the auto trim function of the aircraft. So you need to disconnect the switch here from normal to cutoff. This is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777 and Boeing 787. These red carded suites over here, Boeing 777, Boeing 787, 737 for normal, to cut off these red carded suites like this, as you can see. So then after that you use all the manual trim switch over here all the time. So you disconnect the autopilot and you use the alternate or the manual pit trim command when flying. So you have also the manual pit trim over here. So you trim the elevator up and down like this and use all flight controls. So this is a fly-by-wire aircraft. It has its flight control computers control the aircraft altitude in flight. Like the Airbus aircraft, we have the normal, the alternate, direct mode of flight control computers. Also we have the automatic trim function of the aircraft. It trims automatically itself. Also for the autopilot flight director system panel function, we can also trim manually, or we can override by cutting off these red guarded suites. So like in the Airbus aircraft, when we climb or descend the aircraft or make left and right turns, the computers, the flight control computers, will limit the aircraft and will balance it in terms of G acceleration, where G is the Earth's gravity. So we can make left turns in the Airbus 67 degrees full size deflection, or 2.8 G right deflection, the same 2.8 G or 67 degrees. Also when we release the side full deflection, comes back at 33 degrees. Also we can climb 30 degrees or 1.5 G, descend minus half G or minus 15 degrees. So we have also the alpha. When we fly level, it's 1 G actuated. Also we have the alpha protection system, the alpha floor for 1 G stall when we reach the airspeed and the angle of stall. So we will set the takeoff ground thrust automatically locked, and it will decrease, it will limit the angle of attack of the aircraft until we exit the stall. Also maximum speed, minimum speed protections. So this is a fly-by-wire system. The fly-by-wire for the Airbus, similar is for the Boeing. So I'm gonna show you now the flight management computer setup, the flight plan over here. So the flight plan, very quickly, you can see here we have the display, the mouse pad. We're gonna use the index here, so identity, position, performance, takeoff, approach, and answer status, flight plan. So we go in the index over here. We go in here in the flight plan, control quadrant. So you can see non-CH status, initialize, identities, Boeing 787-900 GNX engines installed. The position, we need to align the IRS, the inertial reference system. Use the coordinates and align with the magnetic north pole and the GPS system and the laser gyroscopes. Performance here, 0 fuel weight plus fuel on board, gross weight for takeoff. The reserve fuel and cruising altitude cost index. The route here, very fast, Zurich Airport, Lszh, origin and destination. Copy paste like this. So we clear the discontinuity here. Runway 14 set, departures. Runways, we can select runway 10, 14, runway 16, runway 28, runway 34. So we'll select runway 14, trans, the seats, other instrument departure waypoints and fixes, do it to alpha. So we have the first legs, then arrivals over here, select runway 16, runway 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we use ILS 14, trans Amity, and trans the stars is other terminal arrival waypoints and fixes, Negria 1 alpha over here. So we have the legs here are created, the route is displayed with blue, is not yet activated. So we need to activate the route here. So we cancel the discontinuity here, Amity, and press the execute button. So we have initialized the reserve fuel 5%, cruising altitude 25,300 feet, cost index 100%, zero fuel weight and fuel on board, and the fuel temperature freezing in flight and the center of gravity. So now the legs will be activated one by one, all the waypoints. So this is the waypoints the autopilot we follow. In flight we connect the autopilot also will be displayed in the display with a purple line. We have also the flaps for takeoff, 15 degrees over here. Center of gravity trim 23%, 4.25 degrees, and the takeoff speeds V1, V-rotate, and V2. So we have departure, arrival, alternate, VNAV, progress, FMC communication, hold. We can hold over a waypoint here. The route, the legs fix, setup fix, radial, and the navigation radio tune, VOR localizer, ADF, Lszh localizer. So we go back in the virtual cockpit over here. We have a couple more minutes left. So we need to set up here. We're gonna make the engine start demonstration now. So we have the APU to start. The auxiliary power unit is gonna give us electric power and pressurizer. When we turn off the engine, 100 to 200 volts for 100 Hz frequency, left and right engine driving. You can see the contactors, our own primary flight control computers in the auto, air data computer, flight control surfaces over here set, battery, down power, passenger oxygen over here, FD door over here, as you can see, window sheet, rammer turbine, backup hydraulic and hydraulic pumps, left and right engine driving. You can see the faults are displayed when we turn off. So we turn back on and then to the auto position, then to the auto. So we have all the hydraulics on, wing and exit radii over here, on and auto, position, cabin pressurization, outflow valves, climb descent in the manual or automatic, air conditioning, pressurizer for other systems. Also you can see here we have the recorders, cargo and APU fire, electronic engine control for the engine, and the auto start over here, left and right auto start. Fuel jettison, we can dump some fuel, rearm these switch and select the nozzles, how much to remain. So we have the fuel, left and right wing, center, the crossfeed. We can feed either engine without a pump right the tank using the crossfeed or balance the fuel between the left and the right wing like this. So this is the fuel pumps and the fuel booster, fuel valves, fuel booster pumps. So we need to start the engines. Have a couple of minutes left only. So the systems here very quickly you can see. We have the hydraulics, the APU is running, oxygen, liquid cooling over here, electric, left and right IDG, 100 to 200 volts for 100 Hz frequency. The APU is running. Also the battery, charge and discharge voltage and average, and the load set. We have also the hydraulics, the quantity of hydraulic fluid, where the which systems use hydraulic fluid, the primary, the demand, electric C1 and C2, 5000 psi's left and right and center, shut-off valves and isolation valves. So the fuel on board, left and right wing, center tank, 11,000 balance in the center, total 34,000. So you can see the minimum fuel temperature below which the fuel will freeze in flight over here, minus 37 degrees. So the FADEX that control the engines and the fuel temperature now will recirculate the fuel from the left and the right wing and the center tank into the engine components to heat up the fuel, then transfer the fuel back into the fuel tanks. Also the lubricant and the oil, this is the antifreeze of the fuel and oil. Also the APU is fed from the left wing using the DC motor. The long high pressure fuel valves open, feed both engines. The cross feed, you can feed either engine without a pump or either tank. Air pressurizer from the left and right engine. Hydraulic oxygen pressurization. The doors are closed, the cabin can be pressurized. The gear, temperature of the brakes and pressure of the tires. Flight controls over here, you can see the control of the flight controls, climb, descent, the rudder also. And so this is one of the last things we need to do over here, the flight controls, deflections. So we have also the FS display, status over here, maintenance, systems and circuit breakers systems, and the checklist. Last thing, checklist normal menu before start, after start, takeoff, after takeoff, descent, approach, and landing. So we go back in the navigation display. You'll see the flight plan when we fly. So we turn off both engines like this, fuel control in the off position. So you will see the fuel control, the amber color over here indication. The fuel pumps are off. So you can see the outside view. You hear the engine sound is turning off. The Boeing 787 aircraft, also the hydraulics. So we need to restart them. We turn the auto start system very quickly on over here. The auto start, both auto starts. Here the engine auto start. You can see the yellow reconfiguration switches in the overhead. So now we have only pressurizer from the engine to the N2 states. The N2 is the high speed starters have high press compressor turbine with the turbofan to the engine. So above 20% we have only pressurizer right now. Above 20% of the N2 we can let the fuel on. So fuel on, fuel control on like this, fuel valves on, fuel transfer valves on. So we have the auto start is coming up. As you can see, 25%. The exhaust gas temperature, the N1, which is the low speed starters have low press compressor to one of the turbofan towards the engine. Fuel flow, engine per hour, in thousands kilograms or thousands of pounds. So you will see now the yellow indications here. The warnings will turn off as we increase the engine oil pressure, temperature, quantity, vibration of the N2 states of the engine. This is the Boeing 787. The engines are on running with green. So we set the flaps for takeoff over here. Speed brakes armed, and we set the autopilot only. Last thing to do. So you can see we can connect now auto throttle left and right, on and off. The LNAV and the VNAV, flight director off. So we set autopilot disengage if we need. The airspeed set. Also you can set the heading over here and bang angle. Heading select 136 degrees like this. Also vertical speed 0, level out. Descent, you will see a minus sign. Climb, you're gonna see the plus sign. So you're gonna climb like this. Altitude thousands and hundreds. So we set over here altitude. So parking brakes off. Thrust levers increase the engine thrust, and we take the clearance from the air traffic control and we taxi into the runway for takeoff like this. So this is the clearance over here. So we taxi like this. The runway is open for us for takeoff like this, as you can see. So we advance again the thrust levers, need to taxi with alignment in the center line and the heading of the runway 136 degrees. So this is how align with the center line. Advance the thrust levers to full takeoff. Wait. So this is Thomas Hatsios, the German-American pilot flying the Boeing 787. I will start now the flight. Thank you for watching me until now. So now we start the flight. Stay with me until the end of the video. You see the full manual flight of the Boeing 787-900 aircraft. We're gonna use also some autopilot for display, and we come back for landing in the Zurich airport. So we start now the thrust levers, full takeoff, power, everything is set inside the cockpit, as you can see. So we press the side stick down like 5 uh, halfway down or the yoke until we reach 80 knots. Also use a little bit rudder pedal for direction control. So we have 100 knots, 120, 130 V1, we rotate. So we pitch 9 degrees for rotation or less for the Boeing 787. So we won't strike the tail of the aircraft as we climb. We do the same for landing. Use a small pitch attitude, less than 9 or 10 degrees. So we keep climbing. Over here pitch trim a little bit up, also flaps, maybe less flaps over here. So you can see we can leave the hands off from the flight control, so the aircraft can do that. So you can see we are 1,400 feet above the ground, 1,500 but 3,400 above the sea, 2,000 feet above the ground but 3,800 above the sea. The airspeed 180 knots, decrease because we have high pitch attitude. Also the stall speed here, the wind direction speed, also the flaps limit over here. We climb with 4,200 feet per minute. You can see we keep climbing. So we have the data here. You can see again the airspeed, the stall speed we're gonna reach is 120 knots. We're gonna stall the aircraft, so we need to pitch down the aircraft and also increase the thrust levers. Also the terrain around us and the flight plan, this purple line. You can see the terrain below us right now. It's 4,200 feet above the terrain is flying the aircraft right now. So you can see further away more terrain, red, green and yellow, more mountains, also lakes, rivers over here. Since we are in the Switzerland, also the engines set. So you can see the terrain below us is 5,000 feet, and we keep climbing 30 nautical miles. So now we need to start the turn over here. As you can see, landing gear up, so landing gear up. So we keep climbing, depart the airport over here, make the turn now. As you can see, so you can see also the other side flight line over here as we fly. We are beam to the runways over here as we depart. So we have the airspeed, maximum takeoff thrust like this, 100%. You can see again the indications, airspeed, stall speed, altitude 12,000 feet, the terrain and the waypoints we have to fly through. You can see this is the flight plan displayed, this purple line over here. We need to fly through this waypoint, come back and land. The wind direction, speed, the autopilot set here, the engines also setting, and the head-up display as we're climbing. So this is the view of the aircraft right now as we climb. You can see we have the Zurich over here, the Switzerland, beautiful Switzerland view, galactic view. So we need to make a turn now. So this is the Boeing 787. Need to make a turn, delayed the turn here. Follow the flight plan, use some right rudder pedal also as we turn. So you can see we can leave the hands off from the side stick, no problem. The aircraft keeps its attitude, its airspeed heading, everything, no matter we have no flight controls of the autopilot connected. Only an airplane can do that. In the air, fly with the hands off when you trim as much as you should, and you use the required thrust level like this. Maintain level flight, also like this level. Change the attitude, again you stay level, you don't fall off from the air. You stay in level flight, as you can see, make small corrections. So you can see the flight one here we have created. As we fly, we can set the autopilot in a couple of minutes. So we have more minutes to fly, a few more minutes, like 15 more minutes for this video to end, and come back to the airport for landing. So you can see the cockpit now inside after takeoff over here. Also the computer here, as you can see. So we're leveling off here, as you can see, as we're climbing. The airspeed 150 knots, the altitude 20,000 barometric altitude, and nav and VNAV as the autopilot, not yet commanded. So we're gonna use the autopilot maybe for display in a couple of minutes. We need to turn the aircraft back to the airport in a couple of minutes. So we're heading towards Germany, towards us. Also the France in this side. So we have the Germany, Bayern Munich, my homeland over here. Also the Switzerland, the Swiss lakes. You can see the Boeing 787. The view. So we're gonna see now turning in a couple of minutes. We can start the turn now if we wish to turn back to the airport. So we have to use, you can see how we navigate here through these waypoints. It's very important. Also the other side of the flight plan, we can change the view. You see more of the flight plan all the way down. So it's like both displays, also with the ground display with the map. Over here you can see the Negria is the waypoint that we need to fly through. Negria, 30 nautical miles away from us. So we have the airspeed, the altitude, and the waypoint we need to fly. So we're gonna start maybe the turn now. Over here, we also gonna change the waypoint. We have a few more minutes to go back to the airport. So you can see the turn here, the Boeing 787. Also the frozen vapors. So we have the Germany here on this side. As we turn manually. We're gonna use the autopilot in a couple of minutes. So you see how we turn, full manual turn like this. We're gonna use the autopilot later in a couple of minutes. So this is the Boeing 787, the Germany, Bayern Munich over here, Düsseldorf, France, on this side. A much clear view of the Boeing aircraft. as we turn. Maintain altitude over here. So we're gonna be aligned with the flight plan right now as we turn. We're gonna maintain also the autopilot in a couple of minutes for display. We're gonna see how we're gonna use the autopilot panel. So we can engage the autopilot like this. Warning, so we have use. So we reach 25,000, and we need also the autopilot connected like this. We're gonna follow the flight plan now back to the airport. As you can see, we have the autopilot connected for display. Also use Lszh command by the engines also. So we execute now the flight plan again. We're going back. Back to the airport, as you can see. So we need to make a turn here, connect the autopilot later. So now we're flying the correct flight path with the autopilot connected over here. Lost some time. As you can see. So now we have the autopilot engaged for display. You will see how we fly with the autopilot on. You can see all the white lights correspond to the autopilot, and we need to follow the LNAV guidance to the Zui over here. So you can see we have the guidance from the autopilot. We need to change the waypoint now to the next one. So we have direct to waypoints guidance. So we overflying the lakes, as you can see over here with the Boeing 787 with the autopilot connected. One more time. So you can see also the view here. You can see the moon sign as we're flying over, and the Boeing 787, beautiful view over here. Also the star sign, beautiful star sign over here. So we have the autopilot connected, and we're flying over here, as you can see. overflying the Switzerland, the Germany, the France. So we're going back home now, to the airport with the guidance of the autopilot. So this is a beautiful view, the lakes, Germany behind us, Switzerland, also the star sign over here. So gonna maintain also descent rate altitude after a couple of minutes. So we need to descend. We start the descent altitude. You can see autopilot now is engaged over here. So the pilot also here. We need to descend. So we decrease the altitude here, the target altitude, 6,000 feet, and now the vertical speed. So we have flight level change or vertical speed. So we set minus. We set the descent right now, and also speed brakes, flaps up. So now we just start the descent over here back to the airport, as you can see. So we start our descent, and we have 7 more minutes left for the approach and landing over here. So it takes a while for the autopilot maybe to react, as you can see. You can see also the descent. We need to fly also level, flying the waypoints over here is idle. So now we disengage the autopilot. We can re-engage it later as we descend. Now we're flying manually. Keep descending, start the turn for approach and landing over here. So this is the manual turn, as you can see. Have reached almost night sky now. High far conditions. So we need to steep turn, make a steeper turn over here. Use left rudder for steeper turn. So the outside view as we take the turn. So we have the runway in front of us. Keep flying manually like this. And we have 5 more minutes for the approach and landing to the airport. So this is our fire conditions. Now we have to follow this way over here, approach for the airport, as you can see. So this is an IFR condition for us, you can see. Keep descending. We need to follow the flight path here manually. So here we have the flight plan. We need to align a little bit to the left, like this. With the runway, we have the runway in front of us. So we have 3 more minutes left for approach and landing. We're gonna use landing gear down, extended. Also some flaps over here. You see flaps used for approach. So a bit less airspeed. So we need to align here, as you can see. So we have the aircraft, apply some thrust, the outside view. We're gonna use for landing. So you can see we are aligned now with the runway, also full flaps over here. Also we have the Lszh localizer, the instrument landing system we need to use to follow the aircraft here, all the symbology, the airspeed and the altitude. So we have some wind cast, some side wind, a little bit right rudder or left rudder, and all flight controls coordinated fly for alignment with the side wind, as you can see in the wind cast with the runway heading. So we have 1 more minute left for approach and landing. Use a little bit more airspeed, more thrust. So we have to grab the aircraft with the runway if we have side wind like this. We have to decrease also the altitude. So this is us aligned with the runway over here. We're gonna be flaring, we're gonna level off with the horizontal tail for the flare and add some thrust over here for the flare. So a little bit more thrust, more airspeed, more idle. So we're leveling off here, aligned with the runway, and leveling off for the flare, as you can see. So we flare the aircraft like this. So we made a very beautiful flare and touchdown, very professional. So we use parking brakes and thrust reverse, idle and thrust reverse, full thrust reverse for slowdown, as you can see. So align again a little bit with the runway. So here's the aircraft almost full stop, as you can see in the runway. Thrust reverse, and now we are fully stopped, as you can see. So you can see all the landing gear here, the nose wheel is perfectly safe, there is no breakage of any